Okay, so we're starting into homework number 11. The next couple of homework sets are associated with finding zeros of polynomials. And in fact, that's sort of the heart of chapter 4. It's given a polynomial, finding its zeros. What we're doing in this problem actually is kind of the reverse. We're going to be given the zeros, find the polynomial. And the author, Sullivan, the author of their text, is doing that to reinforce this factor theorem, a very important theorem with regard to finding zeros of polynomials and just explaining the nature of polynomials. That says that if x equals c, some number, some constant, is a zero, then x minus c is a factor, and it works both ways. If x minus c is a factor, then of course x equals c is a zero. So let's see how that works out here. You're given in this problem 52, which is a sister to I think your problem 55 in your homework set 11. You're given in this case 3 zeros, plus or minus 2 and 0, and a point, minus 4, 16, and you're asked to find the polynomial that goes through all 4 of those points. So you do this actually fairly quickly. You just say, well, if these 3 points, minus 2, 0, and 2, are zeros, then the associated factor with each one of them is x plus 2, x minus 0, and x minus 2. So a polynomial that goes through these zeros is x minus minus 2, x minus 0, and x minus 2. Associated with this 0, and this 0. So if I just clean that up a little bit, here's a polynomial, x plus 2 times x minus 2, that goes through these 3 points, third order polynomial. The problem is it doesn't necessarily go through the point minus 4, 16. I'll show you that really quickly. If I put minus 4 in here, minus 4 plus 2 is minus 2. Minus 4 inserted in for x is minus 4, and minus 4 minus 2 is minus 6. So in this case, f of minus 4 just turns out to be 24 minus 48, not 16. But let me write down a second polynomial here, and that's a polynomial that is just multiplied by a constant. That constant is essentially a scaling factor. It takes this polynomial and stretches it or compresses it. And we can choose a constant, multiplying everything. We can choose it so that we stretch the polynomial just so that it actually cuts to the point minus 4, 16. So in order to do that, let me just see what g of minus 4 is. I guess I just did that. It's minus 48, but I multiplied by a, and I want it to be 16, all right? And I can have what I want if I let a be equal to 16 divided by 48, or minus 1/3. And so here comes the answer, the polynomial that we're looking for. I'll put it over here to make sure I get it on the screen, is g of x is equal to minus 1/3 x minus 2, x plus 2. There we go.